Okay, so for today what we're going to do is we're going to get into a little bit more of the motors. In a previous lesson, we discussed what a motor consists of and how it's made, the different windings, what the stator is and what the rotor is. So today what we're going to be getting into is a little bit more of some of the bigger motors that we commonly see in HVAC. So first one that we're going to get into is your permanent split capacitor motor. So in order to increase a motor's starting torque of a motor, you can insert a capacitor in series with the start winding. Okay, so in a PSC motor, this capacitor is going to remain in series while the motor is operating. There is no switch or any sort of relay that removes the capacitor from the circuit. So it's that capacitor that is in a permanent split capacitor motor that adds to the starting torque of that motor. Where are you going to find PSC motors? You're going to find them in your condenser fan motors. You're going to find them in residential furnace blower motors. Pretty much are your primary areas of where you're going to find a PSC motor. So PSC motors have moderate starting torque and intermediate running efficiency. These motors are used primarily for small compressors or direct drive blower and fan applications. That's what a PSC motor is going to look like. Okay. Well, what's nice about PSC motors is that usually they're going to have the nameplate stamped right on there, and you can get a lot of information on the type of capacitor the motor uses, which is right here where it says cap. This is a 5 microfarad 370 volt capacitor that is being used for this type of motor. So if the capacitor happens to fail for whatever reason, you could just reference the nameplate and you can get a replacement for that motor. It also gives you your rotation, it gives you your voltage, hertz, and horsepower, as well as RPMs, which are also very good information to have, especially if you have a motor that has a failed start winding or a failed run winding. So you can get a replacement motor and with little problem. In fact, if you look at the the wiring diagram here, this looks like this is actually a multi-speed PSC motor. So we have, it looks like a red wire is a low speed, a blue or orange wire is going to be medium speed, black is high speed. My white or purple or yellow is my neutral, and then my 2 brown wires is actually for your capacitor. The next one that we are going to get into is your CSCR motor, which is a capacitor start and induction run motor. Okay, they use a start cap and a start relay. Okay, the motor, once the motor reaches again 75% of its rated speed, the start capacitor is removed from the circuit. CSCR motors have a very high starting torque and are used in residential and small commercial compressors. You may see them in beverage coolers and in small reach-ins. Your CSCR is a capacitor start, capacitor run motor, and are the same as the permanent split capacitor motor, except they have a start capacitor that is wired to them. So a start capacitor in a high capacitance capacitor will provide the motor with additional torque when starting. Once the motor has been started, the start capacitor must be taken out of the circuit using a switch or a relay, and these devices are called start components, and this is covered in the next session when I get into it. The motor also can be abbreviated as CSR, which stands for capacitor start and run. Okay, so here's a diagram of a capacitor start, capacitor run motor. Now you'll notice that you have a start switch here, which could be a centrifugal switch. So right when this motor initially starts, everything is energized. Your run, your start capacitor, run capacitor, and your start winding are all energized all at the exact same time. Once that motor reaches 75% of its rated speed, that switch is going to open, which will now remove the start capacitor from the circuit. However, the start and run winding are still energized, but you have a run capacitor in there that is just helping that motor go along and continue spinning at its highest efficiency. So if a motor windings are not marked, you can honestly use an ohmmeter and check for your resistances. You're going to check between all three windings. The winding measuring with the highest resistance between the start and run, that is going to be your common or your neutral wire. Once you find your C, check between C and the other two terminals. The one with the highest resistance is going to be your start winding. The one with the lowest resistance is your run winding. The best way to do this is to write down CSR in a triangle on a piece of paper, and make sure you write down each measurement. If you are in doubt, always go back and do it again. Okay, motor speeds are shown in RPMs. RPM stands for revolutions per minute, and this is a measure of how many times per minute that shaft is going to rotate. Sometimes you will need to figure out RPMs for a motor, because if you don't have the right RPMs on a motor, sometimes you will not going to be moving the correct amount of CFMs across a heat exchanger or an evaporator coil or a condenser coil. So you have to figure it out what type of RPMs you're actually dealing with. To figure out RPMs on a motor, you're going to use the formula frequency times 120 divided by the number of poles, and that is going to give you your RPMs. So here are a couple of wiring symbols for your motor. Here is your shaded pole motor. Notice that all it is just one winding. There is nothing in there to take that winding out, so once we energize it, the motor spins. Here you have a CSCR diagram, which is what we just went over. Here you have a split phase motor. There is your centrifugal switch. Once the motor reaches 75% of its rated speed, that switch is going to open and is going to remove the start winding from the circuit, leaving your run winding in play. You have your PSC motor, which is basically nothing more than your run and start windings energized all the time, except it has a nice little capacitor in there. And that's it.